Hi students, welcome to the next topic from gravitation. And last class we have learnt about variation of acceleration due to gravity. Because of two factors we have learned about variation of gravitational acceleration due to gravity because of height and because of depth. Today we are going to learn about the next two subsections, which means variation of acceleration due to gravity because of other two factors. What are the other two factors? We have already listed: due to the shape of earth and due to the rotation of earth. So how the rotation of earth and how the shape of earth will affect the acceleration due to gravity. So let's move to the next topic, the third one, variation of acceleration due to gravity. So we'll write variation of g due to the shape of earth, due to the shape of earth, variation of g due to the shape of earth. We know earth is not a pure sphere, it is more or less an elliptical shape. Okay, so it is like a major axis and minor axis are associated with an ellipse, you know. So earth is not a sphere. Earth is not a perfect sphere. We can write earth is not a perfect sphere. Earth is not a perfect sphere. It is having helical shape. It is having elliptical shape. It is having elliptical shape. So earth is not a perfect sphere. Earth is not a perfect sphere. Earth is having an helical shape. So which will containing this axis is called major axis and this axis is called minor axis. And this radius, I am saying the equator radius, and towards upside this is called the polar radius. So equator radius and polar radius, two things will be there. Okay, so let's assume that we know the acceleration due to gravity equation is gm divided by the radius of earth r square. I also told you we can also write these equations like g into mass of earth divided by radius of earth this square. Both are same. Here me equal to m and re equal to r. But in this case, if you are calculating the acceleration due to gravity at the equator is equal to gm divided by r equator square. And if you calculate the acceleration due to gravity at the pole, you can see gm divided by r pole square. Two equations. So we know like equator radius is much greater than that of polar radius. If equator radius will be high, means acceleration due to gravity at the equator is less than acceleration due to gravity at the pole. So this is the key point in this area. So when you are moving from equator to pole, so the next point I am writing, when you are moving from where to where? Equator to pole. The question is, what happens to your weight? Equator to pole. Equator acceleration due to gravity is very lesser. You are moving to pole. When you are moving from equator to pole, I know weight mg equator is less than mg pole. When you are moving from equator to pole you are moving, your weight increases. This is a very important point. Your weight increases. When you are moving from equator to pole, your weight increases because equator acceleration due to gravity is lesser. So you have less weight at equator and more weight at pole. So here you have less weight. If you are looking for your weight will be at equator, it's less, and here you have more weight because acceleration due to gravity at equator is lesser and acceleration due to gravity at the pole is higher. So this is the variation of acceleration due to gravity due to the shape of Earth. Earth is not a perfect sphere, it is more or less an elliptical shape. Okay, hope this is clear. We'll move to the next, the fourth one. So this is quite simple. There is no complexity here, no big mathematical equations are not here. Okay, so perfect. So let's move to the next one. What is the fourth one? Can you tell me what is the fourth one will be here? Variation of acceleration due to gravity due to the rotation of Earth. Earth is rotating, right? Earth is rotating every 24 hours. It completes one rotations. So the fourth one, variation of G, acceleration due to gravity due to the rotation. You have to write every point on your notebook. Rotation of Earth. Notebook is the highlight here. Again I am telling. A variation of acceleration due to gravity due to the rotation of Earth. We know Earth is keep on rotating, right? So for mathematical simplicity, we are always assuming Earth as a sphere, but Earth is not a perfect sphere as I told before. So now Earth is rotating. Suppose there is a mass will be here, m will be here. It is attracting towards the center with an acceleration with a weight called mg. And whenever this Earth is rotating, there is something called, as I told in laws of motion, we have one outward force, and this outward force is called centrifugal force. Okay, centrifugal force. In rotational motion, centrifugal force is mr square. Okay. We know in centripetal force, we know the centripetal force Fc will be equal to mv square by r. This is acting towards the center. Similarly, centrifugal force is also mv square by r. Magnitude wise both are same, but in opposite direction. This is what? Towards the center. Towards the center. Away from center. Away from center, acting outward, acting outward. It's not towards the center, it's acting outward. We know V is equal to R omega. If you substitute it will be here. You can see mr square omega square by R. You will get mr omega square. This is what we are written will be here. Mr omega square. V is equal to R omega. These things we are learning in rotational motion. So mr omega square, this is just an equation is coming, no other stuff will be here. Okay, next let's assume with respect to the horizontal, this angle is theta. Then with respect to this horizontal, the angle is theta. If this angle is theta, what is this angle will come? The total angle is 180. So this angle is 180 minus theta. This angle is 180 minus theta. So mg is a vector quantity, mr omega square is a vector quantity. So let's write mg is a vector, mr omega square is also a vector. So resultant of two vector, is equal to is r. What is called r? Here you can see mr omega square is a force equal to mass into acceleration. R omega square is an acceleration which is acting in this direction. And mg, that is also a force, we can also call it as weight. Mass into acceleration, ma, generally is called force. If instead of a, g will be there, we will call it as weight. So mg, this is a force, this is a force. So this is a vector quantity and this is a vector quantity. So these two vectors will have a resultant will be there, right? These two vectors will have a resultant vector will be here. And this resultant vector, this I am writing as mg effective. This is the effective weight experienced by a person. So the mg effective, this is a resultant vector, this is equal to, how will find the resultant of two vectors? I know the resultant of two vectors are equal to root of a square plus b square plus 2ab cos theta. This is the way we are finding the resultant of two vectors. Here you have to assume the body will be here. The body is at a distance of how much angle? Theta degree from the horizontal. So we know our effective weight. So because mg is acting towards the center, because of the earth rotation, one outward force will be here. That outward force is mr omega square. So if you are asking, hey, what is your actual weight? My actual weight, I cannot say it is mg. No, my actual weight is also affected with what is called mr omega square. So this mg effective is my real weight of the body at this point. That is the intention. Okay, if earth is not rotating, what you can say? There is no omega, there is no omega is called angular velocity of earth. If earth is not rotating, you don't have mr omega square. So your mg is equal to mg effective, both are in the same direction. Now mr omega square is come. Why it is came? Because earth is rotating with a certain angular velocity called omega. So one vector like this and one force vector like this. So you have to consider your weight mg towards the center, and you have to consider this mr omega square outward. So the resultant of these two will give rise to your effective weight. Okay, now if your weight is 63 kilogram, say if your weight is 63 kilogram, which means mg effective is 63 kilogram at this point. It's not mg effective, because it is depends upon the mr omega square. If no mr omega square will be there, mg is equal to mg effective. Because of mr omega square, you have two vectors, you have to find the resultant of two vector. That resultant is another force. This is a force, this is a force. So resultant of these two forces is another force. That force is your original weight. That is your original weight. This is not your original weight. This is not your original weight. This is a force because of motion. This is a force because of your weight. But this is not your original. Your original weight is this one. So now we will substitute in these equations what are the things will be here. So the resultant is mg effective is equal to root of a square, first one. So mg the whole square plus mr omega square. So mr omega square whole square to plus a square plus b square plus 2ab cos theta. So 2 into mg into a into b, mr omega square into cos of 180 minus theta, cos of 180 minus theta. Okay, so you can see here m square will come, m square will come, here also one m square will come. All m square will take out of the root, then it become m, that m and this m will cancel. So what is coming balance? G effective. G effective is equal to root of g square plus r square omega raised to 4. Okay, m is gone. 2gr omega square plus 2gr omega square. Correct, Anna? M is going out. 2gr omega. Cos of 180 minus theta. Cos of 180 minus theta. We'll put all sin t coffee. This is a mathematics, right? All sin t coffee. Here all are. This is like 0 degree, 90 degree, 180 degree. This is 270 degree. Again it is 370 degree. 180 minus theta. This is 180 line. So 180 minus theta means you will come here. Less than 180. So here sin, all sin t coffee, sin and cosec, sin in the reverse, sin and cosec is positive, all others are negative. Here what is coming? Cos. Where cos will come? Cos will come in the fourth quadrant. If you are adding cos of 270 plus theta, 270 plus means you will go into this fourth. 270 minus theta means you will come back. 270 plus means you will go. So if you are writing cos of 270, let me explain. You are writing cos of 270 plus theta, then I will say cos 270 plus theta means sine will come. So I will write it as sine theta, and this is positive. And this is positive. Cos 270 plus theta will come to this quadrant and it is positive. But now here cos of 180 minus theta. Cos of 180 minus theta means you will come to this quadrant. Will come to this quadrant. Cos of 270 plus theta means you will come to the fourth quadrant. Fourth quadrant cos positive. So positive. Now 270 plus theta. Odd number vandana cos inde next sign edukana. Ipo cos of 90 plus theta. Cos of 90 plus theta, like that, sin theta will come, right? So similar to that. So now here we have cos of, our context is cos of 180 minus theta. Cos of 180 minus theta means second quadrant. Second quadrant is S means sin and cosec positive, tan and cot positive, cos and sec positive. So 180 minus theta means cos 180 minus theta means it will fall will be here, and here sin and cosec only positive, all others are negative. So cos 180 minus theta is negative. Negative of what? Minus cos theta. That's all. Minus cos theta. Now we have to go for further simplifications. Here we have to do some calculations. What is called omega? Omega is 2 pi divided by time period. Time period means what? Time period is the time required to complete one rotation. Earth will go for one rotation in 24 hours of time. So 2 pi divided by 24 into 60 into 60. So this value is very lesser. Very less value. Okay, very less value. If omega is lesser means if omega power 4 is very less, very less, is very less. Omega itself is less. You can assume like omega is equal to 0.1. So omega square means how much it comes? 0.01. Omega raised to 4 means how much it comes? 0.0001. So if you are taking the square or power 4 of a very small number, you can assume like 1 by 2. 1 by 2 it's a small number, right? 1 by 2 means what? 0.5. 1 by 2 square means what? 1 by 4. 1 by 2 raised to 4 means what? 1 by 2 raised to 4. 1 by 16. Very less. So that's what I'm saying. If you are taking a small number, if you are squaring it, if you are making it the fourth power, then its value will be very reducing. So omega power 4 is very less. Omega 4 can be neglected. Neglected means that is almost equal to 0. That is all. Omega raised to 4 is almost equal to 0. So I need this space. Okay, so I am clearing this area. Let me keep the diagram will be there. Hope you have written along with me the rest of the notes. If not, pause the video and complete this notebook. Okay, as I always telling, like this is one advantages of these online classes, because portions will be moving little faster, because we don't want to wait for you to complete the notebook. You can anytime you can write the notebook. So let me go will be here. G effective will be, we have written over here. So let me keep it will be here. So omega raised to 4 can be neglected. Balance steps. G effective is equal to root of G square plus this term will goes to 0. So 2 gr omega square cos theta minus. Okay, again, so let me take G square outside. G square outside means minus 2r omega square cos theta divided by G. Okay, G square if I take it outside means 1 minus. Okay, so whole power 1 by 2. This is correct, right? Whole power 1 by 2. G square take it outside, 1 minus 2r omega square cos theta. So G square will come out of the root. So what we will get if G square will come out of the roots? We will get only G, and within bracket 1 minus 2r omega square cos theta by G whole power 1 by 2. Now we know one mathematical equation, 1 minus x raised to n equal to 1 minus nx. This will now provided modulus of x less than 1. This is a mathematical condition. Here we know this is less than 1 because omega square is very less. Not like omega 4, but omega square is less. So this whole value is less than 1. So we can apply this formula. So g into 1 minus nx. This whole term is called x. Nx, n means what? 1 by 2. So 1 by 2 into x. X means 2r omega square. 2r omega square cos theta whole divided by g. So g into 1 minus 2 get cancels. R omega square cos theta divided by g. So further I am expanding g into g minus r omega square cos theta. This is called what? G effective. So this is called the G effective equation. Very important. Very important. Very important for your entrance examinations. Quite important. G effective is equal to G minus R omega square cos theta. R omega square cos theta. Okay. Theta is this angle. So let me consider at equator. At equator. Equator means you are where? You are will be here at this point. Okay. So what is the value of theta? Theta equal to 0 degree. There is no theta. Now you are here. You are here means you are at an angle of theta. Now you are here means theta equal to 0 degree. So G effective is equal to G minus R omega square cos 0. Cos 0 is 1. So G effective is equal to G minus R omega square. Important. If you are at equator, you have to use these equations. Next, at pole. If you are at pole, pole means this will be here. Okay. So at pole means this will be here. So at theta equal to how much degree? 90 degree. What is cos 90? Cos 90 is 0. So you can say G effective is equal to G, because cos 90 is equal to 0. So this term will be here, absolutely go. So G effective is equal to G. Remember these 2 points. So acceleration due to gravity, variation of acceleration due to gravity, due to the rotation of earth, G effective equation will be here. At equator, theta equal to 0, substituted here, we got these equations. And here theta equal to 90, you substitute will be here, you will get these equations. Okay, hope this is clear to you. Okay, we'll do a couple of questions related to this stuffs, whatever we have learned. Based on this, we'll do a couple of questions. Okay, fine. So variation of acceleration due to gravity depends upon the 4 factors: due to height, due to depth, then due to what else is called? Due to rotation of earth, due to shape of earth. Okay, rotation of earth is little derivations will be there. G effective equal to G minus R omega square cos theta. This formula is important. If you know this formula, for pole you can substitute theta equal to 90 degree. For equator you can substitute theta will be equal to 0 degree. That's all. So it's very simple normally to do this piece of stuff. So we'll do couple of questions. Okay, write the question. Find the weight of the person. Find the weight of the person at a depth of r by 2. At a depth of r by 2 from the surface of earth. From the surface of earth. His weight at the surface of earth is 100 Newton. We need to find out, what's the question? Find the weight of the person at a depth of r by 2 from the surface of earth. His weight at the surface of earth is 100 Newton, which means based on the given data we are writing mg is equal to 100 Newton where at surface. Next, we need to find out the weight of the persons, which is called mg dash. We need to find out mg dash at a depth of, what is g dash? 1 minus d by, mg dash will be equal to m into g dash is equal to what? G into 1 minus d by r we are substituted. So if you expand mg into 1 minus d by r, we know mg is called weight at the surface 100, 1 minus at a depth of r by 2. So d is r by 2. In an earth surface, I told this depth is called d and center to this distance is called how much? R minus d. Total radius is called r. So divided by r. R will get cancelled. So 100 into 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2. 1 by 2 into 100 is 50. So its weight is 50 Newton. Okay, remember this. Important to know, important to solve it. Of course, will be there. Okay. Next question. If you learn this one, it's very easy to tackle questions for Neet and JEE examination. There are 2 questions normally asking from this topic, Neet as well as for JEE. Next question. Next question is related to the rotation of earth. Okay. What should be the rotation of earth? What should be the rotation of earth so that the person feels weightlessness means no weight, weightlessness at the equator. They are asking speed, rotation of earth. So it is related with the rotation of earth. We know rotation of earth will be G effective equal to G minus R omega square cos theta at equator. At equator, theta will be equal to 0 degree. So G dash will be equal to G minus R omega square. But person feels weightlessness means no weight, weightlessness, which is called mg effective is equal to 0. If mg effective is equal to 0 means G dash will be equal to 0. So what you will get? 0 equal to G minus R omega square. Omega is equal to root of G by R. Important. Omega is equal to G by R. What is omega? So they are asking rotation. What should be the rotation of? What should be the speed of? What should be the speed of rotation of earth? Speed I missed previously when I writing the question. So please add this. What should be the speed of rotation of earth so that the person feel weightlessness at the equator? So this is the speed of earth. This is important. Okay, this relation is important. Speed of earth. Next, if they are asking time period, if question is asking time period, this is a bonus point for you. If question is asking about time period, this is a bonus question. Question is asking about time period. What is time period? Omega is equal to what? 2 pi by t. Rest will be same. Right hand side will be the same. Is equal to root of G by R. So t is equal to 2 pi into root of R by G. R is called what? R is the radius. Okay, radius to that point. Okay. So let's move to the next topic, and which is called gravitational potential. So write on the heading called gravitational potential. Gravitational potential. Okay, what is called potential? Normally this is very much related with the normal our potential energy. Say for example, we have a ball which is placed in the ground. So normally we'll say the potential energy equations generally are called mgh. H is the height. Now this is at ground, so I'll say at ground potential energy is equal to 0, because the reason is h is equal to 0. Now I keep this ball at a height of h meter away, so I can say potential energy is equal to mgh at a height h. At a height h. Is this very clear to you? So potential energy is equal to mgh. At ground potential energy is equal to 0, because h is equal to 0. At a height h, potential energy is equal to mgh, which is at a height of h meters away from the ground level. H meters away from the ground level, which means ground is the reference point from where it is h meter. From ground it is giving h meter. Let me take another example. You are saying ordered pair 2, 0. This is one example and this is a second example. You are saying ordered pair 2, 0, which means in a graph you will mark x is equal to 2. From where you are taking? From the origin. X is equal to 2 and y equal to 0. So ordered pair 2, 0. So here the 0, 0, that is origin is the reference point. Origin is the reference point. In this example, ground is the reference point. Ground is the reference point. So everything will have a reference point. In case of gravitational potential, that concept is taken into account. Infinity is the reference point. So you can write in gravitational potential, infinity is the reference point. Infinity is the reference point. Is the reference point, which means we can say potential at infinity. Potential at infinity is equal to 0. We will, another way we will write V infinity is equal to 0. So potential at infinity is equal to 0. That is the reference point. Okay. So now let's see the definition of gravitational potential. So always I can measure potential with respect to some reference point. Here the reference point is what? Infinity. In case of a graph, reference point is what? Origin. Okay. Now we are going to define what is exactly called gravitational potential. So you can write gravitational potential. The next point, gravitational potential is defined as the work done to move a charge, to move a mass from infinity to that point. Which means potential at any point. Potential, we always say like a potential difference. Now in the previous example I told ball will be here, and now the ball is at a height of h meters away. So here potential is equal to 0. Here potential energy is equal to 0. Let me make it clear. Here potential energy is equal to 0. Here potential energy is equal to mgh. We will say potential difference. We will always say potential difference. Okay. So potential, gravitational potential is defined as the work done to move a mass from infinity to that point, which means I am doing a work from infinity to say a point I am taking as point P over a mass called M. This is called, so work is doing from infinity to P. Potential will write final minus initial. Potential at P minus potential at infinity is equal to work from infinity to, I am doing a work, which means, what this means is like, I have a mass capital M over here. Okay, I have a point infinity here. This mass is at a distance of r meters away. Distance is r meters away and the point is called P. Now the potential at P is P and infinity is 0. So the amount of work done to bring a mass is small mass. So this mass is not moving, this is fixed. What about this mass? This mass is moving. So I am spending some energy to move this mass from infinity to the point. So very simple, this is a mass called M, another mass M is placed fixed will be here. I want to calculate the gravitational potential here due to this mass, So what I will do, I will take a mass, small letter mass M, and I am taking from infinity very far away and keeping to the point P. There I am spending some of my energy. That energy is called W infinity to P. I am spending an energy to move from infinity to the point P. So this infinity is, so this point is called infinity. So we have 2 points. One is the point P, which is r meter away. Another point is infinity. So this is the amount of work done to move a charge. Which charge? M. Sorry, not the charge, the mass M. So work from infinity to P over a mass called M. What is this mass? M is the moving mass. If you do like this, you will get the potential at P. Due to which mass? Due to capital M mass. Okay. So if you want to find out potential of a capital M mass at a distance of r meter away, that point is called P. That is called the potential at P. So potential at P is because of capital M. How to find? Work done. I have to spend some work to move from infinity to P divided by the mass called M. That is called gravitational potential. Now we want to derive an expressions for the gravitational potential. Okay. So now let's move ahead. We know if you have two masses, capital M and small m at some distance away, r meter away, we have a gravitational force F is equal to Gmm by r square. If this body is moved slightly over a distance, for example, I am taking r plus 1 meter. So now my force will be equal to F is equal to Gmm by r plus 1 the whole square. So which means for every slight, for every slight movement of, for every slight movement of m, F is changing, F is changing. So that is F is keep on changing. F is keep on changing with respect to the change in distance. With respect to the change in distance. With respect to the change in distance. Okay. F is keep on changing with respect to the change in distance. In that cases, how we will calculating the work? Work is doing from infinity to the point P is equal to force is changing. Force is changing means integral F dot dx. F work. F means we want to find out the work. So integration of from where to where we are moving? Infinity to the point P. So from here it is infinite distance. The point P is at how much distance? R meter away. R, infinity to R. F into dx distance I am considering as dr. So we are bringing in this direction F, and the distance is reducing also in the direction. So the angle between them is 0 degree. So F dot dr, if you are writing, we can consider like integral infinity to R. For a variable force this equation is applicable. So we will say whenever a variable force comes, whenever a variable force comes, integration will use. When a variable force will come, integrations will use. We have to use the integrations. So F dr cos of 0 degree. Cos 0 is 1, of course you know. So we have to expand this one. Hope you have written this side. So I am clearing the board. You can pause the video and you can complete the notebook as usual. So I am saying perfect. So fine, perfectly. So work done from infinity to the point P, integral infinity to R, force and equations between the two masses. F is equal to g mm by the initial, the distance. I am bringing to the distance R square. It is changing with respect to R. F is equal to g mm by R square into dr. Cos 0 is 1. So now we are integrating. G is constant, capital M, small m is constant, and rest of things integral over infinity to R, 1 by R square into dr. What is 1 by R square? 1 by R square integral 1 by x square integral is equal to x raised to minus 2, which is equal to x raised to n plus 1 divided by n plus 1. This is a standard formula. We will substitute here. Minus 2 plus 1 divided by minus 2 plus 1. So minus 2 plus 1 means minus 1. Minus x raised to minus 1, which is equal to minus 1 by x. This is the basic mathematics. The basic mathematics principle we are applying, we will get minus 1 by x. So g mm divided by g mm into r power minus 2 plus 1 divided by minus 2 plus 1, and integration limit we have to apply infinity to r. So g mm minus divided by r, we will apply the limit infinity to r. If you apply the limit minus g mm by r, limit apply ma r, minus again one more minus g mm by infinity. Some quantity divided by infinity is what? Infinity is a very high value, so this will be goes to 0. So the potential at P minus potential at infinity is equal to work done from infinity to P divided by the mass called m. So if you divide with m, what you will get? Minus g mm divided by r all divided by m. Small letter m will get cancel it outside. So what we will get? The potential at P, potential at infinity is 0, is equal to minus gm divided by r. Gm divided by g capital M, not small m is already get cancelled. So in short I can write potential at P is equal to the continuations minus gm by r. So this is very important. Potential at P at the point P is equal to minus gm by r. Okay, fine. Hope this is clear to you. So I would like to summarize this one, this topic summary. I would like to summarize this one. If you have kept a mass m at a distance of r meter away and the point is called P, then the gravitational potential Vp at this point is equal to minus gm divided by r. So this is the summary of this one. So at a distance of r, the gravitational potential is equal to minus gm divided by r. That is the concept behind the gravitational potential topic. Okay, perfectly. Every potential is a scalar quantity. Gravitational potential in second year also you will learn something called electrical potential. So every potential is a scalar quantity. Potential direction illa. Potential has no direction. So potential is a scalar quantity. So write the next point. Potential is a scalar quantity. Potential is a scalar quantity. Important. Okay. Okay. Next point. Next heading. Potential due to a ring mass m along the axial position. Potential due to a ring mass m along the axial position. Which means that what mean? I have a ring whose mass is m, whose radius is r, along the axis at a distance of x. We need to find out the potential at the point P. Vp is how much? This is what we need to find out. This is quite simple. Okay, so this is a complete one. So here we will consider small mass called dm mass. So every mass is called dm. So if you take one mass from here, dm over will be here. This is at a distance of root of r square plus x square. Okay, so potential due to a small mass. So the potential due to a small mass, which is called dm, is equal to minus g into dm by x square. Not x square. This distance is given as r, so I am giving as minus gm by r. R distance away. Here, if I am considering one dm mass, because of this dm, the potential will be here. How to find the total potentials? We are integrating over here. Very straightforward. Minus g into dm divided by r. So v is equal to minus gm divided by r means what? We are resubstituting for r. R square plus x square. Here what we have done means dm. Dm we are integrating. Integral dm is equal to m. So integral dm is equal to m, because we have small dm. Many dms will add it up. We'll get total called dm. Okay. So next couple of points we are writing. Gravitational potential. The next point. V at center of the ring. What is the potential at the center of the ring? At the center of the ring means x will be equal to 0. If you substituted x will be equal to 0, what you will get? Minus gm divided by r. Okay. The next point. V at larger distance. Which means this is at larger distance, which means x is very much greater than r. R is another very small value. So r square is very much less. Correct? If r is 0.1 meter, r square 0.01 further less. So r square can be neglected. So v is equal to minus gm divided by root x square. Root x square means x. So potential at a larger distance and potential at the center. These two values has to remember. Okay. Perfect. Why? Good. We'll do one question to make the things better and clear. The concept is to better and clear. We'll take one question and we'll solve it. Okay. So fine. Okay. As shown in the figure, there are two bodies. As shown in the figure, there are two bodies. M, mass M, and radius 2r. And another one, mass 2m and radius r. What is the potential? Means gravitational potential at the point y. So we have this diagram. One is mass m and having the radius called 2r. So this is separated by a distance of another body. The distance between them is 2r and its radius is called r and its mass is called 2m. And this point is called x and this point is called y. That was the ultimate aim. So you can see in the diagram we have 2 points x comma y. One body of mass m, another body of mass 2r, 2m mass and r radius. We need to find out potential that will be here. So so for this one I am giving this as number 1 and number 2. So potential at y is equal to, I need to find out here. So 2 masses will be here. So how many potentials will be there? 2 potential. For 1 mass minus gm by r for 1 mass. So 2 mass means 2 times minus gm by r. So potential at y is equal to potential due to sphere number 1 along the axis. So if you are calculating potential will be here due to this sphere along the axis. So here one potential due to 1. Second one, potential due to the second sphere itself, V2, where V2 is at center. Clear? So because of 1, the potential is here along the axis. What is along the axis? General formula, minus gm divided by root of r square plus x square. Potential at the center, what is the general formula? Minus gm by r. Now we will substitute the values. This is a general formula. Along the axis for the first one and center for the second one. Now we will substitute the formula. R square plus x square. Okay. So we will substitute. We need to get the values for this one. So minus g. This is in the first body mass m. So m substituted. Root of radius square. R is how much will be here? 2r. So 2r the whole square plus distance from the center to that point. That is called x. X is equal to how much? 2r. So 2r the whole square. Plus second body minus gm by r. Mass how much? Minus g into 2m. Divided by its radius is r. That's all. We can simplify this. Minus gm divided by root of 4r square. For 4r square means 8r square minus 2gm divided by r. So if I am taking minus gm outside, how much will come? 1 divided by 4 into 2 so 2 root 2r plus, how much will come here? 2 by r. You can further simplify, else you can stop. It will be here if you would like to have. Okay, so we are going to find out the potential at the point P. There are 2 masses will be here, so 2 potentials will be here. Potential due to m, the formula along the axis. Just 5 minutes before we have taken. and for this body the potential is at the center. So potential at the center equation is this one. Potential at axis general formula. Now we'll substitute. Mass is m, radius is 2r, x is distance from the center, which is called 2r, substituted here. Second body at the center, general equation minus gm by r. Mass is how much? Minus gm to 2m divided by r is the radius. What is the radius? R. We substituted and we solve it. Okay, hope this is clear. This is one area of gravitational potential. Hope this clear, and yeah, we'll see in the next class with the next topic. Thanks for watching the video, and yeah, have a good study time. Bye.